So limits have some basic properties. So for these properties, B and C are going to just represent real numbers, N is going to be a positive integer, so positive whole number, and F and G are going to be some functions. So the first rule is the constant rule. So if you take the limit as x approaches some number of a constant value, so like the limit as x approaches 1 of 2, the limit is just going to equal the value of 2. The identity rule says that as you take the limit of x as x approaches c, you're just substituting in the c value, right? Makes kind of common sense. For coefficients, if you have like a number times a function, you can pull that number out front of the limit and then just take the limit of the function and multiply it by the constant. Sum and difference rule kind of makes a little bit of sense, right? You can split up the addition or subtraction of two functions into two separate limits and then just add and subtract their values. Same thing for product rule. You can take the product of two functions, split them apart, take the limit of each of them separately, and then multiply them together to get your answer. It works the same way for quotients. So for division, the only stipulation there is that the limit of the bottom function cannot be equal to 0 because then you're undefined. It works the same way for powers and roots as well. So if you have an exponent of a function, you can take the limit of the inside function and then just raise your answer to that power. And then same thing for the radical. You can pull the radical outside of the limit, take the limit of the basic function on the inside, and then take the radical of that answer to get the overall value. So we're going to apply these limits in limit properties in a couple of different ways just to practice them. So for our first problem, we have rewrite using the properties of limits. So we don't know what C is, just kind of like, can you use all of those properties to find the best way to kind of find the limit value? So in the top, we have a radical. So we can take the limit inside of the radical. And then we have a sum as well, so I can break up the sum. And then over, we have a product in the bottom, right? X times g squared, so I can take the limit as x approaches c of x and multiply that by the limit as x approaches c. Now I could say g squared, but with our power rule, I can take that squared power to the outside of the function, right? And just take the limit of the inside. Now we can break it up a little even further than this, right? So 3 times x, we can use that constant rule to pull the 3 out front, and then we know from the identity rule that the limit as x approaches c of x is just c. So we can break this down a little further. So this is going to be the square root of 3c plus the limit as x approaches c of f of x all over. Now here in our denominator, right, we have another identity rule. So the limit as x approaches c of x is going to be c, and then times, we don't know what the limit of g is. So we're going to leave that as a limit symbol and leave that square on the outside, right? So this isn't something that you would necessarily be asked to do on like an AP question just to rewrite it, but it is something that you're going to use when you know what the limits of these things are, and you're probably doing them intuitively in your head. We just want to make sure that we have like the definite rules written out for us so we know that they're all working. Another great way to use our limit properties is to use some given information, like the 3 pieces of information below, to find some overall limits. So if we look at our first problem, we have the limit as x approaches 3 of 2 times f of x minus 4 g of x. So if we're using our limit rules, right, this is going to become 2 times the limit as x approaches 3 of f of x minus 4 times the limit as x approaches 3 of g of x, right? So we're using that sum and difference rule to break the f and g into 2 different limits, and we're also pulling those constants out front with the constant multiple rule. So, or I guess I should say the coefficient rule. Different books call them different things. And then you're just going to substitute in. So the limit as x approaches 3 of f of x is 8. So we're going to get 2 times 8 minus 4. The limit of g is negative 2. So this is going to be 16 plus 8. So our overall limit is going to be 24. I'm going to give myself some division lines here just so the work stays a little separate. Right, we can do the same thing in our middle problem. We have the limit as x approaches 3 of 2 g of x all squared, right? So I'm going to square the 2 first. So 2 squared is 4, and then I'm going to pull that out front. And then I'm going to have g squared as well, so I'm going to take the limit as x approaches 3 of g of x first and then square my answer. So I'm going to get 4 and then times negative 2 squared. So that's going to be 4 times 4, which is 16. All right, our last one combines all 3 of the functions and a bunch of different rules. So I'm just going to move. Let's see. Let's get this out of the way. Okay, so if we have the limit as x approaches 3, we have a cube root in the top. So we're going to have the cube root as the limit as x approaches c of f of x over the limit as x approaches c of g of x. Using our quotient rule, we're just taking the limit of the top and bottom separately. Right, using our coefficient rule, pull that 4 out front and then take the limit of the function. And then we have our sum and difference rule here. So I have the limit as x approaches. Why did I write c down there? Whoops. Oh, and I wrote it up there too. Wow, okay. Right, we're taking the limit as x approaches 3 of x and then adding it to the limit as x approaches 3 of 7. Right, so notice that I'm keeping my limit notation there because I haven't taken the limit yet. So the limit is kind of like an operator. So until you do the operation of taking the limit, you need to keep the symbols there. You don't want to drop your limit notation midway through the problem if you haven't actually taken the limit yet. So here I'm going to get the cube root of the limit of f is 8, limit of g is negative 2, plus 4, the limit of h of x is 5, and then the limit as x approaches 3 of x is going to be 3, and the limit of 7 is just going to be 7. So the cube root of 8 is 2, we have over negative 2, plus 20 over 10,